Welcome to Summarize Science. Today we're asking a wild question: can an AI think like an engineer? This recent paper explores whether large language models, the AIs behind tools like ChatGPT, can design and build complex, working machines from scratch. The core idea is to test two key concepts: compositionality, which is how different parts are assembled, and functionality, which is what the final machine can actually do. It's one thing for an AI to generate a 3D shape, but it's another thing entirely to create an assembly of gears, wheels, and levers that all work together to achieve a goal. To test this, the researchers created a virtual playground called Besiege Field, based on the popular machine-building game Besiege. This environment gives the AI a set of standardized parts and a physics engine, so it can build a machine and then immediately test if it works or falls apart. They gave the AI agents two main challenges. First, build a car that can drive as far as possible. Second, and perhaps more impressively, build a catapult that can launch a boulder a long distance. The researchers tested several different agentic workflows, which are just different ways of organizing the AIs to solve the problem. One method used a single AI to do everything, while another used a team of AIs, including a designer, to create a first draft and a refiner to critique and improve it. A third, hierarchical approach had a meta-designer, AI, create a high-level blueprint that other AIs had to follow to build the machine piece by piece. So how did they do? The results show that this is an incredibly difficult task, but not an impossible one. The most powerful models, like Google's Gemini 2.5 Pro, were able to consistently construct machines that actually worked and achieved the goal. Amazingly, we can even get a glimpse into the AI's thought process. The models generate a chain of thought, explaining their reasoning for why they are placing certain parts in specific locations, showing a basic understanding of physical principles like balance and leverage. Of course, the AIs also made a lot of mistakes, highlighting the current challenges. Common failures included putting parts in the wrong orientation, attaching pieces to the wrong parent block, or completely misunderstanding the high-level blueprint. To see if they could improve the AIs, the researchers also used reinforcement learning. This basically means they gave the AI a reward for successful designs, teaching it over thousands of trials to build better and more effective machines. This training did help, but it also revealed that the AI currently prefers to make small, detailed adjustments rather than exploring entirely new and creative design strategies. It's more of a tinkerer than a revolutionary inventor right now. So, let's recap the key points. The researchers showed that today's top AI models can, in fact, perform compositional machine design. They can take a goal, reason about the physics involved, and assemble a working machine in a simulated environment. The team-based, hierarchical approach worked best, but the AIs still struggle with precise spatial reasoning. This work is a significant step towards a future of automated engineering. Imagine an AI design assistant that can help engineers brainstorm, test, and refine ideas for everything from new cars to complex robotics. While there's still a long way to go, this research opens the door to a world where humans and AI collaborate to build the machines of the future. Thanks for watching Summarize Science.